We need to take a look at about how to use the Pythagorean theorem. We've learned this neat little trick that when you have a right triangle and it has two sides given to you, you can actually use this Pythagorean theorem, this relationship, to go find the missing third side. Well, um, in story problems, they're not going to tell you that, hey, this is the Pythagorean theorem. They're sometimes not even going to give you a diagram so you can't even see the right triangle situation. Instead, you're going to just get something like this, and you're going to have to read it and not have any clue where it's leading you. And when you look at the ACT, this problem could just pop up in any given time, and you've got to have a good enough understanding of the Pythagorean theorem that you can actually wade into it and draw this out and discover the Pythagorean theorem on your own. So let's take a look at it. Example 1. The bottom of a 12-foot ladder is placed 5 feet away from the wall. The top of the ladder resting against the wall. How high above the ground is the ladder? Well, draw a picture. So let's draw that 12-foot ladder. Let's kind of slant it because anytime you lean a ladder against a wall, it's going to be, kind of leaning into it. We know the bottom of the ladder is about 5 feet from the wall, so we'll draw a little line right there. Probably label that 5 feet. And then, hey, how about we draw another line or actually draw a wall straight up that the ladder is leaning against? Now, the top of the ladder is resting against the wall. And we want to know how high above the ground is the ladder, at least that top part of the ladder, okay? And so basically, we just want to find the distance from the top part of that ladder down to the ground, and that's a right triangle. So we can just literally find our legs, pop in what information we can. The A is 5, and the hypotenuse is 12, so that's going to be the C, and we just go and solve. Same thing that I taught you the other day. So the top of the ladder is about 10.9 feet high above the ground. That's what they want to know. That's what we discovered once we drew the picture. Um, Actually, let me go back here. These ladder story problems, they pop up quite a bit in different grade levels and different contents. So just get used to these ladder questions, okay? This is pretty much how you do it. Now, example 2, this is another one that they usually use directions. So John leaves school to go home. So do something to draw a school, maybe a square. Maybe you just write the word S or the word school, or maybe write the letter S to represent it. And then it says John walks 9 blocks, or excuse me, 6 blocks north. So we need to draw a line showing it's 6 blocks north. So we need to go above it, north. 8 blocks west, represent that. And then you have John sitting there, and they want to know, well, how far is John from the school? And they don't want to retrace the steps of 8 blocks west and 6 blocks north. They want to know how far directly from the school to where John is right now. So there's that red dashed line. And again, you see the right triangle formed. And so we just take the 8 and the 6 and we plug them in for the legs. And we solve for the hypotenuse, the C. So Johnny's about 10 blocks from school now. Now, example 3 is a little bit tougher, but you'll see these occasionally too. But examples 1 and 2, those are the most popular versions. Example 3 is all about this river. So let's take a look at this. Scott wants to swim across a river that is 400 meters wide. So let's go ahead and draw this river, and let's label it 400 meters wide. He begins swimming perpendicular to the shore he started from. Now that means that Scott is right here, and he wants to dive straight into the water and swim straight across the river. And if they want to know how far he swam, if it was just like a lake, well, that'd be 400 meters. But the problem is that there's the current in this river. And even though he wants to go straight, he can't because there's a current that's going to be pushing him. In this case, let's just have it go to the left. And so while he wants to go straight across, when he starts swimming, that current's going to be pushing him more and more and more and more to the left, but he's still swimming to the other side. And before he knows it, he's been pushed down the river about 100 feet. So that's what's going on. So from here to where he wanted to be is 100 feet difference. And we know that it's a 400-meter wide river. So we've got that triangle set up, and he actually swam this distance in the red dashed line here. So how far did he go? Well, it's a Pythagorean theorem setup. We need to find the hypotenuse. So we take it, plug in our leg information, work out the problem, and we come out to be 412.3 meters. So these story problems, as much as you wish that they would tell you, hey, it's going to be a right triangle or it's going to be Pythagorean theorem, it's not going to say it in the problem. You need to do some sort of layout on the paper so that way you can start playing with the scenario and seeing that it makes that right triangle. And it'll serve you well going into higher levels of math, and just keep at it. Some of these questions are very hard, others are very simple.